Hi everyone, welcome to the 7th video of our chapter Straight Lines. In this video, we will be proving the ratio theorem and working an example using this theorem. The ratio theorem is used to find the coordinates of an unknown point in a straight line using the ratios between the known points. So for the proof of this theorem, consider this line P2, P, P1 with coordinates x2, y2, x bar, y bar and x1, y1 respectively. The ratio of P, P2 is m and the ratio of P1, P is n. The points Q, R and S are there to help us in this proof. In the triangles drawn here, we can see three similar triangles. They are P, P2R, P1, PS and P1, P2Q. These triangles are similar to each other because their corresponding angles are equal to each other. For the proof of this theorem, let's consider the triangles P, P2R and P1, P2Q. Since these two triangles are similar triangles, we can take the lengths of their sides as a ratio to each other. So, P2R of this triangle over P2Q of this triangle is equal to P2P of this small triangle over P2P1 of this big triangle. So P2R can be written as Y2 minus Y bar and P2Q can be written as Y2 minus Y1. P2P is M and P2P1 is M plus N. So now if we simplify this equation, y2 minus y bar into m plus n equals m into y2 minus y1. Finally, we get a value for y bar. So y bar equals my1 plus ny2 over m plus n. This same procedure can be done to obtain the values of x bar. To obtain x bar, we need to use the ratio PR of this small triangle over P1Q of this big triangle equals P2P over P2P1. That gives us x bar minus x2 over x1 minus x2 equals m over m plus n. Finally, we get the equation for x bar. X bar equals mx1 plus nx2 over m plus n. Now we have an equation to find the coordinates of these two unknown points using the coordinates and the ratios between the known points. So these formulas are the ratio theorem formulas. Let's take this question. Here the unknown point P divides the line segment into the ratio 1:2. Since we know the coordinates of Q and R, we can find the coordinates of P using these two formulas. If we take M as 1, then N equals 2. So x bar equals 1 into minus 16 plus 2 into 5 divided by M plus N, that is 1 plus 2. Finally, we get x bar equals minus 2. Similarly, y bar equals 1 into 24 plus 2 into minus 3 divided by m plus n, that is 1 plus 2. So finally we get y bar equals 6. So now that you have learned this new theorem, test your knowledge by answering the questions given in the description below. The answers are also given for your reference. Now for the tip of the day. Sometimes the point given divides the line externally. For example, take this line PQ. Here, the unknown point R is outside the line and it is divided in the ratio 3:1. Some people prefer to use another formula when it is divided externally. However, I recommend using the same formulas. So for this question, even though the unknown value is outside the line, you can simply substitute the values into the equation. But remember, you must first get the ratio of PQ. So here it is 3 minus 1. So this ratio is 2. Now you can use the formula. So 13 equals 1 into 7 plus 2 into x bar divided by 1 plus 2. So that will give us x bar equals 16. Similarly, 5 equals 1 into 6 plus 2 into y bar divided by 1 plus 2. This gives us y bar equals 4.5. That brings us to the end of this video. Remember to subscribe to our channel and click the bell to keep yourself updated on our weekly published videos. Until we meet again, take care.